In this session, we are going to deal with another important factor in all our day-to-day life, that is electricity. Most of us will be knowing that electricity is being used in our homes to run different appliances, isn't it? Like your fan, your fridge, your TV, your laptops, everything. But in this session, we are going to deal how electricity is produced, what contributes to electricity, and what are its different applications. So what do you mean by electric current? It is the flow of electrons through a conductor. A conductor is something or a material that conducts electricity. The device which causes the flow of electrons through a conductor is called as a cell, and a group of cells contribute a battery. How does these electrons contribute to electric current? That is, the electrons will flow from the negative terminal to the positive terminal. That is, if you take a battery, it will be having a negative terminal as well as a positive terminal. So, if you connect this cell into a circuit, the electrons will flow from the negative terminal to the positive terminal. We have already stated that flow of electrons through a conductor contributes to electric current, isn't it? So, how will the electric current and electrons flow related? That is, if the electrons flow from the negative terminal to the positive terminal, then the electric current will flow from the reverse position, that is, from positive terminal to the negative terminal. And this is the general direction of the conventional current that we use. So, the main equation that connects the electric current with the charge and the time taken is I equals Q by T, where Q represents the quantity of charge and T represents the time. So, electric current can be represented as the rate of flow of charges through a conductor. As we have already said, only the conductors will allow the flow of electrons, isn't it? So, electric current means it is a rate of flow of charges through a conductor, or the quantity of charges flowing through a conductor in unit time. That is, I equals Q by T. So, I means current representation, Q represents the quantity of charge and T represents the time. So, the general formula is I is Q by T, isn't it? So, the SI unit or the standard unit of electric charge, which is represented by Q, is Coulomb. It is represented by capital C. So, we can say Coulomb as the charge which is contained in 6 into 10 raised to 18 electrons. So, what was the charge of electrons? Charge of electron is 1.6 into 10 raised to minus 19. So, the SI unit of current is called as ampere, which is represented by capital A. So, we can find a relation between Coulomb and the ampere and the time as 1 ampere is equal to 1 Coulomb per second. That is, 1 ampere can be defined as the current which is flowing through a conductor if 1 Coulomb of charge flows through it in 1 second. So, I equals Q by T and 1 ampere equals 1 Coulomb per 1 second, which denotes the SI units of I, Q as well as T. So, the unit of current I is ampere, the unit of charge is Coulomb and unit of time is second. So, we measure electric current, isn't it? How do we measure electric currents in circuit diagrams? It is used to measure electric current with the help of an ammeter. As you can see in the figure, the ammeter is being connected to the load, to the battery. So, in this figure, it's clear that ammeter is connected in a series manner in the circuit, isn't it? And in the figure which is in the above position, you can see the electron flow and the current, how are they related? You can see the electron flow is from negative terminal of the battery to the positive terminal, whereas which is the direction of current? Current flows in the opposite direction, that is from positive terminal to the negative terminal. So, the flow of electron and the current is in the opposite directions. So, now we need to understand what is electric potential and potential difference. So, electricity is all about how different charges are formed, how potential is related to resistance, and how all this can be related through different ways. So another important term that is essential or inevitable in case of electricity is potential, that is electric potential. What do you mean by potential? If somebody says that you have good potential to have good in arts or sports, or you are very potential in some forms of arts, what do you mean by that? That is, you have the ability to that, isn't it? For example, I am having good potential to draw means you are having a finite skill to draw. Just like that, electric potential is potential connected with electricity. So we have already found out that electric current flows through a conductor. And how is it possible? Is it possible in all cases? No. There is a condition which is applied. That is, electric current flows through a conductor only if, that is, there is a condition. What is that condition? The condition is that only if there is a difference in the electric potential between two ends of the conductor. For example, if I take a conductor AB, so if I need to flow the current between A and B, what should exist? There should be a difference in the electric potential between the two ends of the conductor, that is A and B. So this difference in the electric potential which exists between the two ends of conductor is called as potential difference. And how this potential difference is created? It is done by a cell or battery. A group of cells contribute to battery. So what helps this battery to provide this potential difference is that the batteries are consistent of different chemicals inside it, isn't it? So the chemical reactions which is present inside the cell or battery produces a potential difference between the two terminals or ends of the conductor, and this leads the electrons to a motion, that is from negative terminal to the positive terminal. And what happens finally to the current? The current flows in the opposite direction from positive to negative. That's how the potential difference contributes to the flow of electric current. So I can define potential difference between 2 points, that is A and B of a conductor. Suppose if I am taking a conductor AB with two ends as A and B, I can say the potential difference between the 2 points, that is A and B, as the amount of work done to move a unit charge from point A to B. So I can define it as potential difference equals the work done per charge. That is, the work which I am performing to move a unit charge from A to B is called as the potential difference between that 2 points. So potential difference is being denoted by V, work done by W, and charge by Q. So W denotes work done, V denotes the potential difference, and Q denotes the charge. So potential difference is defined as the work done to move a unit charge from one point to another. That is V equals W by Q. So what is the unit or SI unit of potential difference? It is defined as volt, which is represented by capital V. So what about the other SI units of work done and the charge? So unit of work is joule, isn't it? And what about the unit of charge? It is defined by coulomb, isn't it? So we can write 1 volt as 1 joule per coulomb. So 1 volt equals 1 joule per coulomb. So how can I define 1 volt? 1 volt from this particular equation you can define as the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to another. So in terms of unit, I can write it as 1 volt equals 1 joule per 1 coulomb. So we have already stated that electric current is measured using a meter. So how do we measure potential difference? Potential difference is measured by voltmeter. So as you can see in this figure, it is always connected in parallel between 2 points. So when I connect voltmeter between 2 points, then I will be able to measure the potential difference. So what was in the case of ammeter? In case of ammeter, I connected between them in a series manner. Whereas in potential difference, to measure by voltmeter, I should connect it always in parallel across the 2 points between which I have to measure the potential difference. For example, if I give you AB and I have to measure the potential difference between that 2 points, how should I connect it? I should connect them in a parallel manner across that 2 points, and I can measure the potential difference just like as you can see in the figure. So from this picture you will be able to understand. We have already said what do you mean by electric potential, isn't it? So electric potential can be defined in a separate manner as the amount of work that is needed to move a unit charge from a reference point to a specific point against the electric field. That is, if I consider infinity as my reference point and to a specific point, if I have to bring that particular charge from infinity to that point, I can say it is a work done by moving a charge particle from infinity to other point as the electric potential. So there will be a reference point and a specific point. So where do we perform this? In order to move that charge, we need to do some work against the electric field. So that ability to bring a charge from a reference point to a specific point against the electric field, we should have a resistance to electric field and we should defeat it to bring the unit charge from one point to another. That is called as potential of electric or electric potential. So now we need to find what do you mean by electric circuit or a circuit diagram. Electric circuit means a closed loop path through which a current takes its flow. So as you can see in the figure, it's figure of a electric circuit. So what do you mean by circuit diagram? If we represent the electric circuit through different symbols, then it is called as a circuit diagram. For example, you can see in the first figure, I have already noted it by different pictures, that is light bulb, switch connected to a resistor as well as a battery. In the second one you can see I have given them specific symbols, isn't it? For light bulb I have given a particular symbol. For switch I have given a particular symbol. For battery, for resistor. So for each component in an electric circuit, if I give separate symbols, then if I represent them, then it is called as a circuit diagram. So different components of circuit diagrams are having different symbols. And as physics students, you should be able to identify which are those components corresponding to. So we need to understand which are the different components which is present in a circuit diagram. Among them, the most important one is resistor. As you can see, this is a picture of a resistor. What do you mean by a resistor? Or what do you mean by resistance? Resistance means the ability to resist something or oppose something, isn't it? For example, as students you have resistance to many things, isn't it? Sometimes you will be having a resistance to your studies, isn't it? Just like that, you have a passive attitude to certain things. So that is called as resistance. So resistor is something that resists. So in terms of electricity, how do we define resistor? A resistor can be defined as a two-terminal electric device and it is in a passive nature. And the main duty of resistor is that it can resist the flow of electric current. So as you can see in the picture, it's a very simple element which can be used in an electronic circuit. But it is also one of the most common components which is used as a resistance as the inherent element of most of the electronic circuits. Sometimes it may not be shown, but then also it is an inherent element which is essential in all electronic circuits. And they are usually color coded. They may be having different colors, and according to the different colors they are being installed, they will be having different values. So resistor is simply a two-terminal device. As you can see, there are two terminals which is used to resist the flow of current. So what do you mean by a switch? I am sure you will be able to relate it with your daily life, isn't it? In your home, in your school, surroundings, everywhere, we use switches, isn't it? For example, if you switch on, there will be electricity. If you switch off, the electricity will be cut off. How does it work? So switch is a main device that is used in electrical circuit. So the main function of switch is that it acts as a device which can break electrical circuit by diverting the current from one conductor to another conductor or an insulator. So it can be either an open switch or a closed switch. So according to the working of switch, the circuit can be an open circuit or a closed circuit. So what do you mean by an open circuit? Open circuit means that the contacts are separated and the circuit doesn't work or circuit is broken. So if the circuit is broken or if the circuit is not working, the current will be also not flowing. So what may be the other one? If it is a closed circuit means the complete loop or the path will be completed in the circuit. That means all elements will be connected to each other. Then the current can flow easily, isn't it? So a closed circuit is the one in which all the contacts are touching towards each other. They all are closed. That makes a loop or a path. So such a one will be complete. That is, that circuit will be in a complete manner and the current will be having an easy path to flow. So open circuit is the one in which the switch is being in a on position or they are not closed, they are open. So whereas the closed circuit in which a switch is off or it is not contributing to the flow of current in case of an open circuit, whereas in a closed circuit switch is being in a position so that they contribute to the current flow. So another important one is light bulb. We all have bulbs in a home, isn't it? We use it to see things, to read our books, etc. So how does it work or contribute to electricity? It is a device, of course, that produces light from electricity. So light bulbs turns electricity to light. How? It sends the current through a thin wire called as filament, isn't it? So what do you mean by filament? Or with what material filaments are usually made? Filaments are usually made of a material called as tungsten. So the main property of tungsten is that it emits a light in which the electricity is passed through. So tungsten is having high properties of heat emission or heat capacity, that the emission of light is due to the high resistance offered by this particular material called as tungsten. So the property of tungsten, which acts as a filament which helps in the emission of light due to the high resistance, helps to the light bulb to produce light from electricity. Another important component is our battery. Sometimes you may have played with batteries or opened it to see what is inside. What could you see? You could see that battery consists of a group of cells. So what do you mean by cell? We have already found out that cell contributes to potential difference, isn't it? So cell is a device in which is used to power electrical circuits. It provides the power for electrical circuits to work, isn't it? That's why, for example, if your TV remote is not working, what would you do? You would install it with, or you would put batteries inside it, isn't it? For what do we do that? That is, it needs to provide power to electrical circuit. So a battery, as you can see in the figure, has two terminals, one positive and another one negative. So what is the purpose of these two terminals, that is negative and positive? That is, the terminal which is marked as negative is a source of electrons. We have already said electrons flow from negative terminal to positive terminal. So the source or the point from which these electrons are originating is the negative terminal. That's why the terminal marked negative is called as a source of electrons. So when the terminal which is marked as negative is connected to a circuit, it delivers energy. For example, if you take a normal torch battery also, there will be a combination of cells, isn't it? So what happens is that when we insert the battery into our devices, according to the signs, for example, if the negative sign is given there, we should put the negative sign of the battery corresponding to that. That's why, for example, if you have misplaced or if you have put the battery in the wrong direction, that particular device will not work, isn't it? So a complete circuit can be obtained only if we insert the battery into our devices matching these signs, and that's how the circuit gets the power. So once the reserve of an excess electron inside the cell is over, or if it is finished, then what happens? The energy delivery stops and the circuit breaks. And also, if the battery is drained out, or if the charge of the battery is drained out, means that particular circuit breaks or it doesn't function. So thus a device connected to circuit such as bulb stops working. So that's why if we say the battery is down or the battery has got over and it is not working, we say like that, isn't it? So then what we do? We install or insert a new battery into the device to again start working. So battery is also a very important device which is indeed essential in electrical circuits to power those electrical circuits. So there are many other devices in case of the electrical circuits, but some of the main ones we are discussing in detail. So you can see some of the main components in the circuit diagrams along with the light, bulb, battery, etc. that we have already discussed. So you can see an electric cell which is having a positive one as well as a negative one. Second one as a switch which is called as a plug key. So you can see a open switch as well as a closed switch. A closed switch is the one which contributes to a closed circuit, isn't it? And an open one is the one in which circuit is broken or the circuit or the current is not flowing. There is also the electric bulb which is shown by the particular symbol. There is a resistance R which is shown by particular symbols, and there is also rheostats which is being shown by the variable resistance as in case of this particular figure. You can see along with the resistor, you can see some of the figures added to see that as the rheostats. So there is also ammeter as well as voltmeters. You can see ammeters are always connected in series, whereas voltmeters are always connected in parallel. So the wire joints are also being depicted by 3 lines which is joined in a junction. So another one is a symbol where if a wire is crossing over without joining, it is represented by such a symbol. So each component in the circuit diagrams takes different forms of symbols or representations. So now we have discussed about different terms related to electricity, isn't it? Which were they? They were electric current, potential difference, etc. So one important law which shows the relationship between the potential difference across a conductor and the current flowing through it is Ohm's law. So it is renowned or named after the renowned scientist Ohm. So Ohm's law states that I is proportional to V. So what was I? I is the current. So what was V? It is the potential difference between 2 points or ends of the conductor. So Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference between the 2 ends, and there is a condition for this Ohm's law to be applicable. That is, provided the temperature remains constant. So I proportional to V. The current flowing through a conductor is directly proportional to the potential difference between the ends. So if I changes, correspondingly the V also changes. So I proportional to V or V proportional to I. So in certain manner we can also write it as V by I equals a constant, and that constant is represented by R or the resistance. For example, if I take a particular metal wire, it will be having a constant R. So R is the constant called as the resistance for a given metal wire at a given temperature. So V equals IR or V by I equals R gives the Ohm's law, in which I is directly proportional to V. For example, if I am increasing I, V also increases. If I am increasing I, the V increases. If I am decreasing I, V also decreases. So there is a direct proportionality between the current and the potential difference across the ends. So this is a circuit which shows the verification of Ohm's law. So Ohm's law states that I is directly proportional to V. That is, current flowing is directly proportional to the potential difference across the ends of the conductor. So we need to identify and verify whether I and V are proportional. For that, I have set up a circuit as shown in the circuit diagram. You can see there is AB or the conductor with two ends A and B. There is a key called as represented by K. There is ammeter which is represented using A with positive and negative ends. It is connected in series across the circuit, and V or the voltmeter is connected parallel across the two ends A and B. So first we can use one cell. As you can see, there are different cells in the circuit diagram. Suppose I am using one cell and I am noting the current I in the ammeter. Where do we note the potential difference? The potential difference is noted by looking the voltmeter. And voltmeter I have connected across the nichrome wire or the conductor AB. So we first do the experiment using one cell. In the next experiment, we replace it by using two cells. Then we note a particular current and the particular potential difference. After that, if I read some of the readings in that particular manner, then I again repeat it by using 3 cells and again 4 cells. And in all these cases, I note the readings in ammeter as well as voltmeter. Then now I am going to plot a graph between the current I and potential difference. What will you get? You can see the voltage I characteristics that show the Ohm's law will be a straight line with a slope equals R. R represents the resistance. So if I take the slope of this particular VI graph where current is measured and is plotted in the x-axis and voltage is measured by using the voltmeter, and I am plotting it on the y-axis. So the unit of current is I and the unit of voltage is V. So if I take the slope of this graph, that is R equals V by I. So the slope is R or the resistance. We have already known that V equals IR, isn't it? So if R is a slope, then R equals V by I. So if current increases, voltage will also increase simultaneously. That's why you get a straight line if I am plotting the voltage current characteristics. So the Ohm's law is being valid by verifying it to this particular experiment. So next important one, or the slope we have already obtained, was R, isn't it? In case of the voltage characteristics VI graph. So what is this R or resistance? It can be defined as a property of a conductor. And we have already said resistance means the ability to resist. So in an electrical circuit, what this resistance is of importance? Resistance is a property of a conductor which resists the flow of current through it. According to Ohm's law, we know that V equals IR, or resistance is R equals V by I. That is, resistance is potential difference per unit current. So the SI unit of resistance is derived as Ohm, that is named after the renowned scientist Ohm. So if the potential difference across two ends of a wire is termed as 1 volt, and if I suppose that the current flowing through that particular ends of the wire is 1 ampere, then how can we denote it as resistance? Then the resistance of that conductor is 1 ohm. Since I equals V by R, we can see the current which is flowing through a resistor is inversely proportional to resistance. So I equals V by R. So R and I are inversely proportional. We have already termed that I is directly proportional to V, isn't it? Current flowing is directly proportional to the potential difference. And how resistance and current are connected? I is inversely proportional to resistance. We already know that resistance means to resist or to oppose, isn't it? So if there is more opposition, current will be less. So if resistance is doubled, what happens to the current? The current will be halved. So there is an inverse proportionality relation between current and the resistance. So there are different factors on which the resistance of conductor depends. That is, if I am taking a particular material you can see the resistance of that particular one is dependent directly proportional to the length of the conductor. Here, if I am taking this particular material, then the length is being denoted as capital L. So, if resistance want to increase, we need to also increase the length of the conductor. And it is also directly proportional to the nature of the conductor. And resistance also increases if the temperature of the conductor also increases. And the resistance also increases but in an inverse proportionality to the cross-sectional area. That is, if area increases, then the inverse proportionality applies to resistance. So, area of cross-section of the conductor and the resistance is in inverse proportionality. So, by including all this one, how can I write an equation? That equation is denoted as R equals rho L by A, where L denotes the length of the conductor, A denotes the area of cross section of the conductor, R denotes the resistance of the conductor. Then what is this rho? The rho is termed as resistivity. So, that is a constant that is called as resistivity. So, R equals rho L by A. So, rho is a constant of proportionality which we use here. So, it is called as a resistivity of the material of the conductor. And the SI unit of resistivity is ohm meter. So, conductors like metals and alloys have low resistivity like 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. Whereas the insulators or those materials which do not conduct electricity in a nice manner, such as rubber or glass, have very high resistivity. That means they oppose in a very high manner, isn't it? They have high resistivity of 10 raised to 12 ohm meter to 10 raised to 17 ohm meter. So, both the resistance and resistivity of materials will vary with the temperature. So, the resistivity of alloys, it is found generally higher than that of the constituent metals. It's because alloys will not oxidize or burn so readily at high temperatures. So, because of this reason in which alloys do not oxidize even at high temperature, they are commonly used in different electrical heating devices like maybe your iron box, toasters, etc. And one of the most important element that is used to make filaments of electric bulb is tungsten, as we have already stated, because of its ability of high melting point. Whereas copper and aluminum are generally used to make electrical transmission lights. So, resistance and resistivity of materials are also playing an important role in case of electrical circuits. So, as we have stated, rho is a constant of proportionality, isn't it? So, resistivity is termed as the electrical resistance of a conductor by specifying its particular dimensions or particular constituents composing. That is, electrical resistance of a conductor of unit cross-sectional area and unit length. That is called as resistivity. So, resistivity is a characteristic property of each material. If I take a particular material, that will be having a particular resistivity. So, since resistivity is characteristic property of each and every material or individual material, it is very useful in comparing various materials on the basis of their ability to conduct the electrical currents. So, high resistivity means they are poor conductors. That is, if a material offers high resistivity in a circuit, then they will act as only poor conductors. So, resistivity and conductivity is also inversely proportional. So, the inverse of conductivity is called as resistivity. So, resistivity I may be marking by rho, the symbol, which equals 1 by sigma. So, sigma denotes the conductivity. So, resistivity and conductivity is inversely proportional. So, the resistivity is having the SI unit of ohm meter. So, how is this resistance and resistivity related? We have already stated that R equals rho L by A. R means resistance, rho means resistivity, L means length of the conductor and A means area of the conductor, isn't it? So, resistance and resistivity are connected by R equals rho L by A. And how is resistivity and conductivity connected? Rho, the resistivity is connected to conductivity sigma in a inverse proportionality, isn't it? If conductivity increases, then resistivity decreases, and vice versa. So, rho equals 1 by sigma. So, now we need to analyze how this resistors works in circuit. So, we need to find the resistance of a system of resistors in different combination, in series combination, parallel combination, etc. So, first we can consider resistors in series. As you can see in the picture, I have connected 3 resistors R1, R2 and R3 in series manner, and there is a power supply of voltage V which is having a positive as well as negative terminal. So, the main important character regarding the series connection is that in case of series connection, same current will be flowing through each resistor. So, the current through R1 resistor, R2 resistor as well as R3 resistor will be the same current which I denote by I. So, the specialty of series circuit is that each resistor in the series circuit will be having same current I. So, there are 3 resistors R1, R2 and R3, and the current flowing through each resistor of this circuit is I. And we know that V is IR according to Ohm's law, isn't it? So, I consider electric current as the capital I, and how can we rate the potential? We know that there is V1 potential for resistance R1, there is V2 potential for R2 and there is V3 potential for R3 resistance. So, the effective potential can be defined as V equals the sum of the potential difference across each resistor. That is, the potential difference of the first resistor R1 is V1, the potential difference of the second resistor R2 is V2 and the potential difference across the third resistor R3 is V3. So, the final potential difference of all these resistors is V equals V1 plus V2 plus V3. But we have already said in series circuit the current will be same. So, we know that Ohm's law is taking the form of V equals IR. So, now we are going to find potential difference for each of the resistors R1, R2 and R3. So, in a series circuit we already know that I, that is current, is same for all resistors, isn't it? But we need to find the potential difference across 3 resistors separately. So, potential difference is different for different resistors. So, we need to find it. So, I am first calculating V1 or the potential difference across the first resistor R1. So, how can I turn into that? V equals IR, isn't it? So, V1 equals I R1. And the potential difference for the second resistor R2 can be written as V2 equals I R2. And third one means the potential difference for the third resistor R3, that is V3 equals I R3. So, in these 3 equations, that is V1 equals I R1, V2 equals I R2, V3 equals I R3, you can see I is denoted only by particular letter. There is no I1, I2 or I3. It's because current through each resistor in a series circuit will be same. Only the potential and the resistor value will be changing. So, from the first equation, we already know that the net potential difference is defined as V equals V1 plus V2 plus V3. So, if we substitute for the value of V1, V2 and V3 from 3, 4 and 5 into the first equation, you will obtain as V equals V1 plus V2 plus V3 turns as IR equals IR1 plus IR2 plus IR3. If I take the left hand side and right hand side common component as I as separate one, you can see in the left hand side and right hand side I cancels and I get the effective resistance or the resistance in a series circuit R as combination or sum of R1 plus R2 plus R3. So Rs equals R1 plus R2 plus R3. So if several resistors are joined in series, then resistance of the combination Rs equals the sum of their individual resistors, that is R1 plus R2 plus and R3. And you can see that this sum will be greater than the individual resistance. So Rs equals the sum of the individual resistance, that is R1 plus R2 plus R3. So in a series circuit, the current remains same, whereas the potential difference is changing, and the effective resistance or the resistance in a series circuit will be defined as Rs equals R1 plus R2 plus R3. So the main characteristics of resistors in series is that if I join the different resistance with each other such that there is only one path for the flow of current, then the combination of such resistance is called as series connection or series combination. That is, I am connecting my resistors in a series manner or end-to-end manner. And in case of a series combination, current through each resistor is a constant. So here I denoted is that as I. For R1, R2 and R3, the current was denoted as I, isn't it? So in a series combination, current takes the same value or it is a constant. And also in case of a series combination, the potential difference across each resistor will be different depending on the value of the resistance. So current will be a constant, but the potential difference across each resistor will be different. And you can see the equivalent resistance of the circuit is equal to sum of the individual resistance. So the equivalent resistance Rs equals to sum of the individual resistance, that is R1 plus R2 plus R3. So Rs equals R1 plus R2 plus R3. But one of the main disadvantages of series circuit is that if one component of this particular series combination is fused, then the other components as well as the circuit will also not function. Why is it so? We have already told in series combinations, all of them are joined with each other and there is only one path for the current, isn't it? Or they are having a end-to-end joining in a circuit. So if one component is being off or fused, then it will affect all other components and the circuit will be broken or it will not function. So it is one of the disadvantages of a series combination of resistors. Another important area of discussion is resistors in parallel combination. As you can infer from the figure, three resistors R1, R2 and R3 are connected in parallel combination with a power supply of voltage V, isn't it? And we know Ohm's law takes the form V equals IR. It may be noted that when I am connecting resistors in a parallel combination, the current through each resistor will be different, whereas the potential difference across each resistor would be a constant. That is just opposite to that of resistors in series. So I can write I as the combination of I1 plus I2 plus I3. I1 means it is the current through the first resistor R1, I2 is the current through the resistor R2 and I3 is the current through the resistor R3. So I can write RP as the equivalent resistance of this parallel combination of resistors. In case of series combination, I wrote Rs, isn't it? So here as a denoting of P as parallel, I denote RP. So applying the Ohm's law to the parallel combination, how do we get? We know V equal IR. So I can be denoted as V by R or V by RP, that is the equivalent resistance in parallel combination. We know when resistors are connected in parallel, the same potential V applies to each resistor, isn't it? So now I am going to apply the Ohm's law to each resistor individually. So we know the current is different for different resistors in a parallel combination. So I need to take I1, I2 as well as I3. So I means V by RP. RP represents the resistors in parallel combination, isn't it? So now I have to define or denote it in terms of each resistor separately. So I1 equals V by R1, that is voltage by the particular resistance. Similarly, I2 means voltage by that particular resistance. In all these cases, the potential is same. That is the peculiarity of parallel circuit, isn't it? And I3 means V by R3. So, I1 equals V by R1, I2 equals V by R2, I3 equals V by R3. So, now we are going to apply it, combining these second equations and the third A, B and C equation. That is, if we combine both this equation, we would get it as V by Rp equals V by R1 plus V by R2 plus V by R3. How do we get it? Because for both equations of second and 3A, 3B and C, for all of them the left hand side was equal, that is I. So, we can cancel it. So, we can equate the right hand side of both the equations. Then we will get as V by Rp equals V by R1 plus V by R2 plus V by R3. When we look both the equations, you can see the numerators are having a common factor, that is V. So, if I take V outside and cancel on both sides, which is a common factor on the right hand side as well as left hand side, I obtain the final equation as 1 by Rp, that is the reciprocal of the equivalent resistors, equals 1 by R1 plus 1 by R2 plus 1 by R3. Rs was equal to R1 plus R2 plus R3. But what happens here? Here it is a reciprocal of the combination. So, in a parallel combination, the reciprocal of the equivalent resistance of a group of resistance which is joined in a parallel way is equal to the sum of the reciprocals of the individual resistance. So, what are the different characteristics of the resistors in parallel? As we have seen, in parallel combination, current through each resistor is different. So, what stays constant here? The potential difference across each resistor is constant. And we can see if there are more than one path for the flow of current in a circuit, then the combination of resistance is called as parallel. What was series combination? If there is only one path for the flow of current, that is a series combination. But here, if there are more than one path for the flow of current in a circuit, that combination is called as parallel combination. And the potential difference across each resistor is constant, whereas the current is different. And you can see from the final equation 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3 that the equivalent resistance of circuit is always less than either of the resistance which is included in the circuit. So, what is the main advantage of resistors in parallel combination? You can see for your home appliances mostly we use parallel combination. Why do we do so? It's because we can say in the parallel combination, each component will be having different flow of current in different paths. There is not only one path, there are different paths, isn't it? So, if it is a parallel combination of resistors, if one component of circuit is also damaged, it won't affect the other components. That means the circuit will still work without any disturbance. This is because there is presence of more than one path for the flow of electrical current. So, that is main one advantage of resistors in parallel over the resistors in series. So, next we need to discuss about the heating effects of electric current. For example, if you are using the bulb for a long time and if you touch the bulb, you can see there is some heat for the bulb, isn't it? So, along with the light energy, there is also some heat which is surrounding that particular device. So, the electric current is also having some heating effects. So, in order to identify that, this is a circuit diagram. In this, you can see the resistor which is denoted by R. There are two ends A and B, and across the two ends I have connected my voltmeter to identify the potential difference, or if I need to measure potential difference across two ends A and B, I am connecting a voltmeter across it. And through the circuit there is current I flowing. Also, I have connected a cell of plus and minus ends along with key and also an ammeter. You can see the ammeter is connected in series in the circuit. So the I is flowing through the resistor of resistance R, and the potential difference across the ends of the resistor is V, and I denote the T be the time as the charge Q flows through the particular circuit. And how can I define the work done? That is, the work done in moving the charge Q through a potential difference V can be denoted as VQ. That is, W equals VQ. Work done in moving the charge Q across a potential difference of V takes the form W equals VQ. So, the heating effect of electrical current is to be found in terms of electrical energy. So, how can we define electrical energy? Energy is same as the work done. So, this energy transferred is same as the work done. So, we can say it as work done to maintain the flow of current in a conductor as the electrical energy. So, we have already stated W equals Q into V, isn't it? That is the work done to move a unit charge Q across a potential difference. So, W equals Q times V. From the equation of general as I equals Q by T, isn't it? That is, how much is one? If I am asking you the main equation connecting Q, T and I, you would say it as current is the rate of flow of charge per unit time, isn't it? So, I equals Q by T. So, from second equation, I equals Q by T, you can derive Q equals I cross T, isn't it? I equals Q by T, so Q equals I times T. So, by comparing the second and third equations, you would get Q as I times T, isn't it? So, we have obtained an equation for Q in terms of I and T. So, now we are going to substitute third equation in one, that is W equals Q times V. So, for Q I am substituting I times T. From where did I obtain that equation? Because you already know the formula for I, isn't it? I is the charge Q divided by time. So, Q means I times time. When if I take into the first equation and the second equation and third equation, now we are comparing and substituting. So, from the first equation, W equals Q into V. So, for Q I substitute I times T. So, I get the final equation 4 as W equals I into T into V. But we already know the Ohm's law as V equals IR, isn't it? So, in the fourth equation, now I am going to substitute for V. So, what we basically do is, we take an initial equation W equals Q times V. Then we substitute for Q as I into T. Now, we are going to substitute for V. So, V equals I into R. So, if I substitute V equals IR in the equation, you would get work is equal to I into T into I into R. That is, the work done here is same as the amount of heat produced, isn't it? Work done is same as the energy produced. So, I can write H in terms of W. Why? Because it is a heat energy which is doing the work here. So, I get H equals I into T into I into R. That is, H equals I square RT. So, this is known as Joule's law of heating. What do these laws imply? This law implies that if you look the left hand side of the equation, we have the heat produced, isn't it? So, this law implies that the heat produced in a resistor is directly proportional to the square of the current for a given resistance, which is given by I square. Then what else? It is directly proportional to the resistance for a given current, which is denoted by capital R, and also the heat produced in the resistor is directly proportional to the time for which the current flows through the resistor. So, H equals I square RT. So, the heat produced is directly proportional to the current as well as resistance and time. One thing you have to notice, it is directly proportional to the square of the current. So this is known as Joule's law of heating. So now we need to finally analyze what are the different practical applications of heating effect of the electric current. It has many useful applications in our daily life. For many appliances that we use, like for your ironing or your toaster, even if it's your electric oven, electric kettle, the electric heater, etc., are some of the main devices that functions on the basis of this Joule's heating. So remember the Joule's heating equation, H equals I square RT. So the electric heating is also used to produce light as in case of electric bulbs, isn't it? So what happens here is that the filament which is present in the electric bulb should be able to retain as much of the heat which is generated, so that it gets very hot and emits light faster. That is what tungsten does, isn't it? Tungsten is used as a filament, we have already said. So what is the main property is that such elements should be able to get hot very fast and emit light by retaining as much as heat as fast as possible. And so they are not melting at high temperature, that is they can melt only at very high temperatures. They have a capacity to withstand even high temperatures. So high melting point of such elements make them suitable to be used as filaments. For example, the tungsten, it is having a very high melting point of 3380 degrees Celsius. So up to that they won't melt. So that makes it suitable to make in filaments in case of bulbs. So the filament that we use in terms of electrical device should be thermally isolated as much as possible. So the bulbs which are usually filled with chemically inactive gases like nitrogen, argon, etc. Why we are using it? Because it prolongs or it ensures longer life of the filament, that their chemically inactive gases are used inside the bulbs. And one important factor that you have to take care is that most of the power which is consumed by the filaments like tungsten appear as heat, and only a small form of it is in the form of light which is radiated. And another important application of Joule's heating is the fuse which is used in our electrical circuit. What is the purpose of a fuse in a house? It helps to protect the circuit and appliances. How does it protect? What it does is that it will help to stop the flow of any inefficient or unduly high current which is occurring. If any undesirable high electric current is occurring as a sudden, then they will help to protect the circuit and appliances. And how this fuse is placed in our circuits? Is it in a series combination or is it in a parallel combination? You can see it consists of a piece of wire which is made of a metal or an alloy of appropriate melting point. For example, it can be aluminum, copper, iron, lead, etc. What happens is, if a current larger than the specified value or the desired value is flowing through the circuit, then the temperature of that particular fuse wire will increase. As the temperature of the fuse wire increase, this will melt the fuse wire and the circuit will be broken, so that the another appliances which are connected will be saved from further damage. The fuse wire is usually encased or enclosed in a cartridge of porcelain or similar materials with the metal ends. The fuses which are used for the different domestic purposes is dependent as 1 ampere, 2 ampere, 5 ampere, etc. So in this particular diagram you can see the different wires which are present. There is live wire, neutral wire as well as the earth wire. Live wire is the only wire which contains electricity. The electric current will come from the live wire, as you can see in the particular picture. Whereas a neutral wire, the term neutral means it doesn't have any particular charge, isn't it? So the neutral wire denotes a zero potential wire. What do you mean by earth wire? The wire which is connected to earth, isn't it? As you can see from the figure. So earth wire means it is a wires that is connected to deep earth with a metal, and they have a zero potential when they are connected to earth. And how is it useful? That is, the current, we have already said, the wire which contains electricity is live wire, isn't it? So the current that comes through the live wire and then flows back from the neutral wire. So the earth wire which has zero potential and the excess energy during the short circuits is sent to earth back without occurring of any shock or damage. So earth wire will make it sure that if at all some excess energy is produced during the short circuits which happen due to high level currents or unexpected currents, then this earth wire, which is connected to deep inside earth by using a metal, will send that excess energy to earth, so that not the appliances are damaged or even the persons who are touching it are not getting any shock or damage. So earth wire is a safety measure which is used to understand and to find that the short circuits are not producing any additional damages. So now we need to analyze what do you mean by electrical power. Power means it is the ability to do something, isn't it? Or it is the rate at which a work is done. So if we define electric power, it is the rate at which electric current is produced. That is, power is the work done per unit time. The work that we can do if I am given a particular time is called as my power, isn't it? So power can be defined as the work done per unit time. So the work done can be denoted by capital W, the time can be denoted by T. So P equals W by T, which is also written as I square RT. So how do I write I square RT? Because we already have learned from Joule's law of heating, isn't it? Work done or heat produced is same as I square RT. H equals I square RT, W equals I square RT, isn't it? So I am substituting my second equation in one and I get P equals W by T. So instead of W, I am substituting I square RT. So what do you get? P equals I square RT by T. You can see in the numerator and denominator there is a common term T. So I can cancel it, isn't it? So what do you finally get? You get P equals I square R. So power equals I square times resistance, isn't it? But we already know that there is another equation of power, that is P equals VI, isn't it? So if I substitute this one in the above equation I square R, what would I get? I would another get one equation, that is P equals, instead of I square R, I also have the equation P equals VI, isn't it? So if I substitute that, I can get P equals V square by R, isn't it? So there are mainly two equations, P equals I square R, but we know P is VI, isn't it? So comparing both, you will get P equals V square by R. So the SI unit of electric power is watt, isn't it? So watt is named after the famous scientist James Watt. So we can define this as the power which is consumed by a device that carries 1 ampere current when operated at a potential difference of 1 volt, isn't it? Because of the main equation P equals VI, here P is represented by volt, then I am representing V by volt and current by ampere. So 1 watt equals 1 volt into 1 ampere, which I get as 1 watt equals 1 volt ampere. And you know this unit watt is very small, isn't it? So in actual day life or practices, we need a little more higher unit or a larger unit, isn't it? So we usually represent it in terms of kilowatt. So 1 kilowatt is equal to 1000 watt. So since the electrical energy is a product of power and time, the unit of electrical energy is namely as watt hour. So how can I define 1 watt hour? 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. Simply, that is watt hour. That is watt that is consumed in 1 hour. So the commercial unit of electrical energy that we commonly use is kilowatt hour. So instead of watt hour, we use some more larger unit as kilowatt hour. So in terms of joule, if I am representing, I can write it as 1 kilowatt hour equals 3.6 into 10 raised to 6 times joules. So 1 kilowatt hour and joules are related by the equation 1 kilowatt hour equals 3.6 times 10 raised to 6 joules.